Having me. It's a pleasure to be here, and a particular pleasure to follow Mercedes. Hello everyone. Nice to be here. And I was saying it was a particular pleasure to follow Mercedes and to see my smiling mentor Phil in the audience as well. Phil corrected a lot of the mistakes in this talk on Friday on an emergency basis. So today I'm going to talk about RSpace. So what is RSpace? And I realized, like Dataverse, it's not a computational product. So this is slightly a bit different from many of the other talks and for this audience. So what is RSpace? It's an enterprise-scale electronic lab notebook that's designed for use in large research institutions like big universities. What does that mean exactly? Well, you can also think of it as a digital data hub that's used by research groups in the life sciences. It's Google Docs for science with lots of bells and whistles. There's lots of different ways to think about it. And coming back to one of Mercedes' themes, it's also an active data management tool, which we then integrated with an archival data management tool, Dataverse. So I'm not sure if a couple of screenshots will help or not, but if you look on the screen, you can see what the kind of documents you can create in RSpace. So at the top, you'll see there's the workspace, that's where you create and manage documents. Then below that, there's the gallery, which is kind of like the hard drive of your computer, and the two integrate together. And on the left, you can see a structured document, so you can create structures in your documents as well as having simple documents. You'll see on the information panel, you can get lots of information about your documents, which is useful for all sorts of reasons. So what makes RSpace distinctive, which I think is one of the reasons that it fits in well with the data commons idea, is it's very flexible, which is suited to academic research environments where things often change. Connectivity, interoperability, which I'm going to talk more about in a moment, and traceability, which is very important in terms of both IP protection, identifying who did what, made what contributions, et cetera. And also it has support for both molecular biology and chemistry, which are the two core disciplines which use products like these. As a company, something which I think distinguishes us is that we very much developed a product through collaborations with our universities, which are our customers but also our partners. So the product was actually developed in intensive engagement with the University of Wisconsin a number of years ago. And after that, we've continued to work on development with Harvard and other universities. So this is kind of this is our story really. This connected approach, coming back to the interoperability theme which Mercedes introduced. So if you look at this on the left, we have several kinds of interoperability. We have interoperability with data and files, interoperability with instruments, interoperability with tools, and interoperability with repositories. So the idea is that many of the other products which approach this problem are in effect silos. But our whole approach, which we really was informed by the University of Wisconsin, was to be part of an ecosystem. So the ecosystem continues to grow because we understand that researchers, when they're working on their, running their experiments and documenting their research, they need to continue to use all of the other resources which they're already using. So this product is not meant to replace the other tools they're using, but to complement and to supplement the other tools they're using. So you can make links from RSpace to things like OneDrive and Google Drive and Box and Dropbox, where you might be keeping your documents and your spreadsheets. You can also make links to institutional stores where you may be keeping your big data, your sequencing data, or your imaging data if you're involved in life sciences research. We also have integrations with all sorts of tools, both science-specific tools and generic tools. So, for example, with Slack and Microsoft Teams, which are increasingly used as vehicles for communication, with things like GitHub, with Protocols.io, which is, I think, also probably going to be adopted as part of the Harvard Data Commons, which is an open source protocol sharing website or utility, which is becoming very popular. And the list is always growing as well. And plus we have an API so you can build things on top of RSpace yourself. And then finally, at the other end of the spectrum, you can see the Dataverse bubble, I think. So we've integrated RSpace with Dataverse and a couple of other repositories so that it's possible when you're finished with the active part of your search, you need to deposit your data into a repository to make it public. You can do that very seamlessly through RSpace. So this is our story, if you will, and I'm just going to put up again the slide that Mercedes just showed about the Harvard Data Commons. I think you can see with that as background why this RSpace fits in very well with the notion of being part of a data commons and being interoperable with a whole suite of tools. And I think it also comes back to some of the things that Scott was saying this morning about NERC. The idea is not that scientists don't just want one tool, they want to be using a whole suite of tools. And for those to be effective, they need to be interoperable. So just looking at the list here, RSpace is already integrated with Dataverse, integrated with Protocols.io. We are going to have an integration with Jupyter Notebooks, for example. So I think this is a core aspect of the data commons, which fits in very well with our kind of design approach and our philosophy. So we are also going to be working with Scott and others in the coming year on putting RSpace and Dataverse up as pilots on NERC. And some of the things that we'll be looking to do in conjunction with that are the integration with R and Python notebooks, as I mentioned. And this is actually a really practical thing, because if you look at the life sciences, there's a huge divide between the computational side, bioinformaticians on the one hand, who create models, and the wet lab people, which is the long tail of life scientists, which are really users of RSpace. And they might want to cooperate together, but oftentimes cooperation isn't as good as it should be. And there are many reasons for that, cultural, et cetera. But one of the reasons is because they use different tools. So the computationists all use Jupyter Notebooks, and the wet lab people all use things like RSpace. And unfortunately, never the twain shall meet, or often it's the case that they don't meet. So through the integration, we're going to provide a platform that will help in some ways to bridge the gap between those two communities, and that's really an important thing. We are also going to be looking for developing ways of even more enhanced synergies with other tools that are deployed on NERC, Dataverse being a prime example. And something else which is, which I think fits in nicely with the NERC model is this multi-campus collaborations. Unfortunately, at the moment, when we deploy RSpace at Harvard, it's not necessarily seamless for collaborators from outside Harvard to access the Harvard RSpace, and likewise if it's the Edinburgh RSpace or the Wisconsin RSpace, whatever it is. And it's possible, but it takes some work. So when it's deployed on NERC, that will provide a very seamless environment for researchers from different universities all to access RSpace. So we're looking forward very much to the pilot, and also looking forward to helping to kick off the Harvard Data Commons. Thank you.